So let's talk about the first order differential equations. For that, first order differential equations, for that we have to just know what a differential equation is at first. So a differential equation is, suppose one function is function of xy, okay, and the ddx of this function and ddy of this function is also present along with this x and y, and this is getting a function. So this is called obviously a DE or differential equation function. So first order. So we are right now discussing about the first order ODE. So about on this topic we are just discussing about this exact form of this first order ODE. So this ODE means ordinary differential equation. Okay, so ordinary differential equation. So what this exact form means, this exact form means that if we have any differential equation and that which is also an ODE, so we have to just consider the form of that ODE in this way, that m dx and n dy equals to 0. So if our ODE is given in this form, that m dx plus n dy equals to 0, and secondly if we are just becoming able to get del y of m and del x of n which are equal to each other, so this condition implies the exact form of this ODE. So it's not definite that all the time we are just going to get the exact form of any ODE. We can also get the form which is not exact. So which is not exact means there will be not equal to, there will be an inequality in between these two terms. So but those forms or those ODE will also be reducible to exact. So right now we are just going to discuss about the rules with the help of which we will able to convert any reducible form of ODE to the exact form. So the rules are, rule number 1 is the inspection rule. So in this case we have to just find some terms for which the given ODE is not become exact. So the terms we have to just remember, we have to just put in our mind that the terms will be y dx plus x dy. So if this term remains there, about which for which our ODE is not becoming exact, so we can easily take this, we can easily consider this term as d of xy, and we can easily integrate this. So this is the first term we have to just remember, and the second term is similarly y dx if there remains a minus in between this. So for this we are going to use an integral factor, and that will be obviously 1 by x square. So this is an integral factor multiplying with which we will be able to get the exact form of the given ODE. And the third one we have to put in our mind is that y dx minus plus x dy. So in this case the integrating factor is becoming 1 upon y square. Now the second rule is, if now we have we it is given that mx plus ny, okay, no, our ODE is given in this form, m dx plus n dy equals to 0. Okay, and this is not becoming any exact, so we are just converting this into an exact form. So for that, in according to this rule number 2, we just follow two conditions. So the first condition is that mx of our mx minus ny, okay, has to become not equals to 0, of our this given ODE, and the second condition is that m and n will have to homogeneous. Okay, we'll have to homogeneous. So if these two conditions satisfy, then we can easily use this if or integrating factor that will be 1 upon mx minus ny. And now the rule number 3 comes in use. So the rule number 3 is nothing more than this, that for this rule number 3, obviously we are given this n dx and n dy equals to 0 form, and the first condition is similar to the previous rule, that mx minus ny has to really not equal to 0. Okay, has to become really not equal to not equal with 0. If this condition satisfied, then we can easily use this integrating factor, which is 1 divided by mx plus ny, to make our this given ODE, to convert our this given ODE to its exact form. And the rule 5, no sorry, the rule 4, the rule 4 is nothing. For this way, we the condition can be in this way, that this condition is definitely be satisfied by this rule, that if del del y of m minus del del x of n is becoming as a factor, and this n is multiplied with any function of x, if this form or this category remains there, then we will use an integrating factor which we are using till this date. That's our very common known. That's e power f of dx, f of x dx, integration of f of x with respect to x whole to the power e. And the rule 5 is similar to this rule. For that case, the condition will be opposite according to the signs, sorry. Okay, this factor is given, and this m is multiplied with any function of y, and for this case we are just going to use this term as our integrating factor to just convert our given ODE to its exact form. Thank you.